Alright, hi everybody, this is the Math 31 Optimization Review package. This is question 14. We are going to maximize the volume of a cylindrical juice can, okay, given a restriction on its surface area. So here's R and here's H, okay. Now we are going to maximize the volume, which will be pi r squared h. However, we are given some information. We are told that the surface area is 1,000. Now, that surface area is going to be pi r squared. Sorry, I'm getting ahead of myself. A lot of these questions are open-topped. This one is not. So this is 2 pi r squared because there's a top and a bottom. And then the lateral surface area will be 2 pi r h. Okay? So now, what we might do here is, we might really quickly just make this 500 is equal to pi r squared plus pi r h. And I think it should be pretty clear that the thing that we want to solve for here is going to be h. Okay? I've got an r squared and an r here. I could solve for r, but it's going to require me playing with the quadratic here. However, if I solve for h, okay, I will get 500 minus pi r squared all over pi r equals h. And so now I have an expression for h in terms of r, and I can bring that back up to my volume function here. So this will be pi r squared times 500 minus pi r squared all over pi r. That actually works out really, really nicely because the pi's will cancel here and one of the r's will cancel, and so now I'm just left with distributing the r. So this will be 500r minus pi r cubed. Okay, and so now if we take the derivative of volume with respect to r, we'll get 500 minus 3 pi r squared. I was going to do dr by dt, but actually we're taking it with respect to r. And now set this equal to 0, okay, because I'm looking to optimize this, and I'm going to get 500 equals 3 pi r squared. So 500 over 3 pi is equal to r squared, so we'll take the square root of that, okay, which will end up being, well, it's not going to be a particularly pretty number here, but r will end up being plus or minus the square root of 500 over 3 pi. Okay, well, we know that it's going to be positive. Okay, we know that this is going to be a positive value here. So positive, and actually I can pull a 10 out of that. So positive 10 square root of 5 over 3 pi. So that's the radius here. Now, in a question like this, we probably want to go through and get maybe the decimal equivalent of this. Okay, so I will go to my calculator here. 10 times the square root of 5 divided by 3 pi. Okay, and I'm getting that this is roughly 7.3 centimeters. And if I plug that in for 8, well, you're not seeing that, but if I plug that now back in over here for h, okay, I will get, so well, maybe what we'll do is I'll come up here because I got more room here. So we just discovered that r is 7.3 centimeters, h, if I now plug that in, I will get, and h was over there at 500 minus pi times r squared, get that in there, divided by pi r. And I get that h is equal to roughly, I'm going to round this, 14.6 centimeters. Okay? Now, my volume, because the question was also asking me to determine the maximum volume, I'm going to go right over here to figure out my volume. I already know what my radius is, so I'm just going to plug that in, and I will get 500 times my radius minus pi times my radius squared. And I screwed something up there. Sorry, I'm just using my calculator here. Okay, yeah, that makes way more sense. Sorry, calculator just went all wonky on me. This will be, yeah, we'll round that to the nearest tenth. Why not? Centimeter cubed. Just want to plug that in. There we go.